Hi guys, this is Mrs. Spence, and I wanted to make sure that you guys got all the notes for today, even though I'm not going to be there during third block. I'm going to go really fast, and so lucky for you, you have a pause button, and so you can go through the notes and you can listen to what I say, and then you can pause the video and do what I need you to do. But I am going to go through this really fast, so have that pause button handy so that way you can cut and tape and take your notes. So it may take you probably most of the block to get through this, but whereas this video may only be 10 to 15 minutes. So the first thing I want you to do is I want you to cut the title out and put it at the top. Notice this is, we're doing two sections today, 3.6 and 3.7, parallel and perpendicular lines in the coordinate plane. All of this information should be review because it's basically algebra, stuff that you learned in algebra. So hopefully it will be. All right, the first little cutout that I need you to cut is this little example problem right here. And if you notice, what I've got here is it kind of flapping open like this. All right, so this is slope, basic rise over run. The slope formula is y2 minus y1 over x2 minus x1. That's what you did last year. If I give you 2 points, then you can find the slope. And on the back of this is the shows you how we get the rise and the run. So you can kind of look that over. Again, that's just a review. So if you need to, go ahead and pause the video and then create for me this little foldable, just to kind of review rise over run. Next, we're going to do the types of slope. The types of slope, of course, are positive slope, negative slope, undefined slope, which is a vertical line, and horizontal slope, which is a zero slope. And of course, that's a horizontal line. I wrote down under here that these are y equals a number equations, and these are x equals a number equations, just to kind of remind you what the equation looks like when you have those kinds of lines. So go ahead and tape that down right next to it and draw your different types of slope in there and fill in these little spaces. And when you get done, then start the video again. The next thing I want you to do is create for me two lines that have, another line that has the same slope as this line that's given on the paper. If you notice, the slope of this line is a 2 over 4. Rise over run is 2 over 4, which reduces to 1/2. So I want you to draw for me another line on your paper on this little box, and I don't really care where you draw it, but I want this line to have the exact same slope. All right, because you can see right what I wrote right here, same slope. Lines that are parallel have the same slope. All right, you can pause the video and do that. And then we're going to go over here and do perpendicular slope. Perpendicular slope, you want the opposite reciprocal. So your slope is 1/2 on the original line. So I need you to draw a line that has a slope of negative 2 over 1. Opposite reciprocal slope. So that way it kind of goes this direction. Now this graph paper is distorted a little bit. It's not perfectly square, so that didn't make a right angle like it should have, but it would if the graph paper was perfect. So this would be perpendicular. So finish that little clip art out, and then when you're done, start the video again. All right, down here along the bottom, I just reviewed our definitions for parallel and perpendicular. Again, parallel lines are coplanar lines that do not intersect. Perpendicular lines are coplanar lines that intersect to form right angles. And I drew a couple little mini graphs. So you can pause the video and fill those in. And then in this little blank at the end, I just reminded you that slopes of parallel lines are equal and slopes of perpendicular lines are opposite reciprocals. Very important, opposite reciprocals. So pause the video and get all that filled in for me. And in the last little bit of space over here, I have 4 examples. The fourth one I actually had to tape to the top because I ran out of room. So if I get it out of the way, you can see my example and the solution to number 1. You can see number 2, the example and the solution. You can see the solution to number 3. And you can see the solution to number 4, which, like I said, I had to tape on the top. I just made it like a little flap. So go ahead and work those problems and see how you do, and then come back and check them. Next, we have just some couple more things here about writing an equation of a line. So you can tape these down kind of in this order on the next page. You've got how to write the equation of the line. You've got sometimes we're given the slope and the y-intercept. Sometimes I'm given a point and the slope, and sometimes I'm given 2 points. And so I've got to be able to write the equation of the line no matter what I'm given. So the first example says write the equation of a line with slope of -2 and a y-intercept of 5. Oh, you know what? It just dawned on me. Let's go over these things first. We're going to probably need them. So if you want, you can tape them down below or above. It doesn't really much matter. But slope-intercept form, if I was with you, I would ask you what that was. So hopefully you remember slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. And if you need to, you can write yourself a little note. Slope is the m, and b is the y-intercept. Hence the name slope-intercept form. Point-slope form is used when we're given a point and the slope. So that form was y minus y1 equals m times x minus x1. So I have a point and I have a slope, and I use this to write the equation of the line. And then, of course, standard form is ax plus by equals c. And that's just us putting x and y on the same side of the equation and a constant out here on the right side. Sometimes we ask you to put things in standard form, and so that's what it would look like. All right, you do want to make sure that a is a positive number. Okay, that's one of the conditions on this. We like to have a as a positive number, and we want a, b, and c to be integers. No fractions, no decimals. All right, so let's do a couple examples. Let's say I'm given the slope and the y-intercept, like in this example. Write the equation of a line with slope -2 and the y-intercept of 5. So I'm going to plug in my y equals mx plus b, and my equation will be y equals -2x plus 5. If I want it to be in standard form, then I'm going to move the 2x to the other side of the equation, so it looks like this. 2x plus y equals 5. If you have 2x plus 5 equals 2x plus y equals 5, and notice this is a positive number right here, so now you have it in standard form. All right, now we have a point and the slope. So if you have a point, here's the point, and you have a slope, then you can use the point-slope form, which is y minus y1 equals m times x minus x1. And we're going to put this point into the x1 and y1 spot, and this slope into the m spot. So it looks like this. Y minus y1 equals m times x minus x1. Notice we ended up with a double negative there. So you have y minus 4 equals negative 1/2 times x plus 3. Now, if you want to try to rearrange that and get that into standard form, which I don't really have enough room to write it all here, probably the first thing I would do is multiply this by negative 2 on both sides, the reciprocal, so that I would have negative 2 times y minus 4 equals x plus 3. And then I'd rearrange this equation so that, and I'm going to run out of room, so let me grab some more paper. So I have something like this, and maybe you can write this down below if you need more paper. Negative 2y plus 8 equals x plus 3. I'm going to subtract x from both sides to get it over here. And then I'm going to subtract 8 from both sides. That gives me negative 5. And then I want this to be a positive, so that means I'm going to change all the signs. And now it's in standard form. So that would be this middle one. And I'm sorry I didn't give you enough space to write that all in, but hopefully you get the idea. And then the last one is 2 points. So if I want to write the equation of the line containing 2 points, 2 given points, of course first you're going to need to find the slope of the line. So you use the slope formula. y2 minus y1 over x2 minus x1. So I'm going to have 1 over negative 3, or negative 1/3. And then the process is basically just the same as the one we did above. We can pick one of the points. I'm going to choose this one. And I'm going to use my slope, and I'm going to use the point slope form to figure this out. So y minus y1 equals m times x minus x1. So go ahead and do that real quick and see if you get the same answer that I do. And we'll come back together here in about 2 seconds. You can just leave the video going because I'm going to be working it kind of here in the background. Actually, here, I'll just do it right here for you. Y minus y1 equals m times x minus x1. And I would multiply by negative 3 on both sides to get rid of that fraction. Uh-oh, bell rang. And then negative 3y plus 12 equals x minus 1. I'm going to leave the 12 on this side this time. And add 1 to both sides. And here's my equation in standard form.
The following students please cover the office. Sam Sherman, Taylor No,
So,
Carlos Alvarez.
hopefully that helps, and sorry I was kind of in a rush, and feel free to come with questions tomorrow.
Teachers, if you have not done your